What's going on? How are we all doing? Dude, this whole viewer count thing's getting all messed up. I don't even know how many people are even watching. Hello, hello, hello. Anyone there? Ugh, why is it being all finicky today? I don't understand why. What's going on, PlayStation Gamer? Are you any other type of gamer or exclusively PlayStation? Trying to get sponsors? Xbox and Switch. So why not just like rename yourself to Gamer or PlayStation, Xbox, and Switch Gamer? Be trendy. Be really trendy with that one. Or just I play games. How we all doing though? It's like T minus one more month till summer, where you guys get to enjoy staying in your homes again. You know, it's really interesting, like the talks and development that's going on with the district. You know, they are actually building out plans for this potentially happening again. It's crazy. They have like 3-month plans, they have 12-month plans, they have 2-year plans. I mean, it's granted, it's better to be prepared than not prepared. So I mean, it's not this shouldn't be like an alarming thing, but it's just very interesting that it's just like so weird that, you know, like if things do not get better, what if? What if your entire senior year, that's all online? It's crazy. What if? I'm not saying it's going to be. I'm not quoting anyone. There's no, I'm not getting top secret information. But just in the hypothetical universe, you know, as we start easing restrictions and we start going back into society, we could easily be like, oh, bad idea. Restrict everything again. And then senior year, junior year, sophomore year, could be 100% online. But who knows? Who knows what's going on with that? But last lesson in the CPM. Wow, 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 wow. Seems like someone's in my front door. But wow, wow, wow. We are almost done. I just added the 11-2-2, so that should be in your box that you guys can go ahead and take a look at. But let's start going over it. So basically, we solved... I'm going to have to use the full screen because it actually takes up a lot of space. But we actually solved linear equations with 3 variables. And it's just a process of elimination over again and over again and over again. So, for example, in this one, I said that the strategy for us to be able to simplify this would be to pair one equation with the other 2 equations the intention is to eliminate the same variable in both of those two different pairs. So if I pair this middle equation with number 1 and number 3, so if we think of it as 1, 2, and 3, I pair equation 2 with equation 1 and equation 3. What I want to do is I want to try and eliminate the same variable. Now, the variable that I had in mind was going to be y. Because I see that if I did 2 and 1, I have a positive y and a negative y. Those are going to be really easy for me to cancel out. And then if I did equation 2 and equation 3, well, one of them is already negative, so I don't have to do a whole bunch of algebra to make those coefficients opposites. So I'm going to rewrite that. I'm going to pair them up. So equation 1. Let me adjust my headset just a little bit. It's kind of in the way. So equation 1 and equation 2. And then I said equation 2 and equation 3. Now, I said that the variable that I wanted to eliminate was going to be y. Well, my variable is already opposites here, so I can just add these equations together. So if I do that, I'm going to get 3x, those are going to cancel out, plus 2z equals 3. So here's one equation. I'll just kind of underline that in red. My next one, these are not opposites. One's a negative y, the other one is positive 5y. So I want to do the same thing here, but I may have to multiply this equation. Ooh, typo. This should be 7. There you go. So I'm going to multiply the entire top equation by 5, and I'm just going to rewrite it below. So that's going to be 10x minus 5y plus 5z equals 5 times 0 is 0, so equals 0. So now, when I add those together, those will cancel out. So I'm going to get 7x plus 12z equals 7. So now I need to take those two equations and I need to do the same thing. I need to eliminate a variable. So I have completely eliminated y, created 2 brand new equations, and now with those 2 brand new equations, I need to eliminate a variable. And it doesn't matter which one, just pick which one that you feel is easiest. And I think in this instance, it actually might be z. And the main reason is there's a 2 in common with that 12. So that means that to make this opposite, I would only have to multiply that equation by -6. Versus if I tried to eliminate the x, I'd have to multiply one equation by 7 and then the other one by 3 to make them 21. But in this one, I only have to multiply one of them. So rewriting that, I'm going to get -18x and then minus 12z equals -18. And so now adding these equations together, I'm going to get -11x. Those will cancel out. Might equals, and then -11. So if I divide both sides by -11, I'm going to get x equals 1. So now all we have to do here is work our way backwards. Right when you find a value, so I found that value right here, I found x equals 1. We now just work backwards until we find all the variables. So if I take that 1 and I plug into one of the original equations up here, I'm going to have 2 variables. Like if I just look at the top one, x plus y plus z equals 3, I'm going to get 1 plus y plus z equals 3. Well, I have two variables. That doesn't help me very much. So if I take this and I plug it into this one, well, I only have one variable left over. So I'm going to plug that x in. So I get 3 times x, which is 1, plus 2 times z equals 3. So that's 3 minus 3 on both sides. I get 2z equals 0. So therefore z equals 0. Now that I have both of those, now I can plug it into the original. So I get x plus y plus z equals 3. So I'm taking this x and I'm taking this z and I'm plugging it into x and z into the first equation. Now it doesn't matter which equation. You could plug it into the second. You can plug it into the third. It doesn't matter. In this instance, I felt the first equation was the easiest, which is why I'm going to plug it into that one. So then I'm going to minus 1 on both sides. And so I'm going to get y equals 2. So then my final answer, we write it as a point. So my answer is going to be 1, 2, 0. X, Y, Z. And the order that you know how to write them in will be here. We wrote the X first, then we wrote the Y, then we wrote the Z. So X, Y, Z. Yes, these are a lot of work. Yes, these take a little bit more time. All of that is true. We need to be organized. So notice how I grouped that together, then I have that together, and then once I have all the information, that's a little bit more scatterbrained, but essentially, you know, keeping things organized to make things much easier. So problems 2, 3, and 4 are all basically the same. Same idea. Figure out a variable to eliminate. Looking at number 3, a couple of hints. Put in a 0x, and then I would move this x over here and make that a 0y. So it just FYI when you combine those equations, because the z's are the only variable that's in common with all three, try and eliminate the z's. So maybe do equation 1 with this one and equation 1 with the second. So do 1 and 2 and 1 and 3, eliminate the z's, and you're only going to have x and y's no matter what. And then you can go through and eliminate that way. Number 4, it might be easiest to eliminate the x's. And I would actually pair the third equation because it has a negative. And I would pair that maybe with 1 and 2. So then, you know, you're only multiplying one equation by a value to try and eliminate it. Some of the things that are the same with 2 variable, if you get 0 equals 0, it's infinite solutions. So that means everything cancels out, so you only have 0 equals 0. If you get like everything cancels out and it equals a number, so it's a non-true equation like 0 equals 8, then it's no solution. So all of those still apply. Questions on 1, 2, 3, or 4? I say give them a shot, and if you have more questions on it, I'll come back to this tomorrow, or you can ask it in Discord. More than happy to help. So 11.2.2 says find the missing side of the right triangle. So like number 5, I know it's a 45, 45, 90 triangle. So t root 2. That's kind of like the ratio, or x root 2. So that means that this, if I know that this is already 5 root 6 over 2, this has to be 5 root 6 over 2. And then here, this is t times root 2. So that's going to be 5 root 12 over 2. That 12 is 2 root 3. 2's cancel out, so that turns into 5 root 3. So my b is 5 root 6 over 2, and then my a is 5 root 3. My doorbell's going crazy. I want to see what's up. So just give me 1 second. I'm going to be right back. All right, I am back. I apologize for that. Didn't know what the heck was going on. Oh, let me shut the door. Okay. So any other questions with 5 or 6? Let's move on to like 7 or 8. So solving each triangle just means you have to find all the sides and angles. So on number 7, for this right triangle right here, I have A, C, and B. So 43.7. And then 10.5. So we basically just have to find all the sides and angles. You just write them out. And so you can put them all out there. I already know what B is. It's 43.7. I know what C is. That's 90 degrees. I know what side A is. That's 10.5. I just have to find angle A. So angle A is 180 degrees minus 90 minus 43.7. To find side B with my given angle, that's opposite, and I have adjacent. So this is adjacent and this is opposite. So the tangent of 43.7 equals opposite over 10.5. So B equals 10.5 tangent of 43.7. And then my C, that's my hypotenuse. So that's adjacent hypotenuse, so that's going to be cosine. And so I can say the cosine of 43.7 degrees equals adjacent over hypotenuse. Multiply both sides by C. Divide by the cosine 43.7. So we're going to get c equals 10.5 over the cosine of 43.7. And so enter those into your calculator and you're going to get your values. Any questions on that? So it says solve the polynomial inequality. So polynomial inequalities, or any inequalities, we need to find the zeros. Once you find the zeros, you put them on the number line. Test true or false, sign chart, whatever it takes. So for number 9, I have 4x cubed is greater than or equal to 3x plus 1. So I need to find the intersection points. I need to find the zeros. So 4x cubed minus 3x minus 1 is greater than or equal to 0. You brought everything to one side. P's over q's. So the factors of 1 over the factors of 4. So I'm going to get plus or minus 1, 1/2, and 1/4. Now I need to use polynomial division to be able to find those. So for example, if I wanted to try 1, I get 4. I don't have an x squared, x to the first, and the constant. Add straight down, multiply, add, multiply, add, multiply, add. So 1 works. Yay. So this gives me 4x squared plus 4x plus 1. This will factor into 2x plus 1 squared if we did the whole Xbox method thing. And I still have the x minus 1. So my zeros are going to be 1 and negative 1/2. Put those on the number line. Because it says equal to, I know it's going to be a solid circle. And now I just need to test the region and see, because it says greater than or equal to, I know that's going to be positive numbers. So because it's going to be positive numbers, I could just use the sign chart to be able to figure it out. So if I plugged in -1, 2, negative, anything squared is positive, so this is automatically a positive. 1 minus 1 is negative, so negative times a positive is a negative. If I plugged in 0, positive times a negative, so that's also going to be negative. And then if I plugged in like 2, positive times 2 minus 1 is positive. And so that's going to be a positive. So my solution is going to be this positive region here. So that's going to be from 1 to infinity. So remember, any inequality, you find the zeros, number line, and test. For this one right here, it should be number 11, but it says number 13. Just to get rid of the 2 in the denominator, if you multiply everything by 2. So if I do 2, it cancels out here, and then so that should become 2x plus 4. So you'll get x cubed plus 2x squared is less than 2x plus 4. Bring everything to one side. Same idea, p's over q's, and solve it. All right, so like I said, give these a shot. Give 1 through 4. And then tomorrow, we'll take a look at that. I'll have some study guide material ready to go. Like I said, it's just going to be the final study guide. We're going to be practicing and going over the final. Because we're pretty much done. Pretty much done. Thanks, guys. Any last questions before I end this stream? Great. I hope you guys are healthy. Hope you guys stay safe. And I appreciate that you guys were here today. So, all right. See you guys later.